Here for our Trypan Blue Viability with an Auto 1000 webinar. My name is Stephanie Saldi, and I am the new Tech Support Specialist here at Nexcelom. So getting started, we can take a look at what topics we will be working with today. First, I'll give a brief introduction to the Cellometer Auto 2000 software and what it is and what types of cells it is used for. And then we'll familiarize ourselves with the software and go through the home screen for a little bit. And this will be followed by how to perform the Trypan Blue Viability Assay. And then I'll discuss some of the data management features for the instrument very briefly. So the Auto 2000 uses a single bright field channel to image cells. It is suitable for cell lines and primary cultured cells for concentration viability analysis. The viability analysis is done using Trypan Blue, and the user can do a cell size analysis of the live and dead cell population. It's an important aspect of the Auto 2000 that separates it from some of our other instruments is that it is a standalone touchscreen instrument, meaning no external computer is required. It's all built in, and it can take up that much less space on your benchtop. And we can take a look at the different cells that are supported. The first sample is a cell line that is a slightly mixed population. This sample has irregularly shaped cells and some clusters, which our software has done a good job counting, and also a bit of debris that was excluded. Another sample is this SK-MEL2 skin cancer cell line that also has some irregularly shaped cells, and they're still able to count those two. The third example is an A549 cancer cell line, and we can see how well our software was able to cluster these cells. So in short, the Auto 1000 is good for counting mammalian immortalized cell lines, cultured primary cells, and also the NCI-60 cancer cell lines, which some of you may know there are quite a few of those cell lines. So next we're going to get familiar with the Auto 1000 software and home screen. So this is what you see when you start the instrument, and this is where you select your assays. Starting at the top, it shows our current selected assay, in this case the Cell Line Viability Trypan Blue assay. Our current assay is outlined in red to show it is selected. Number 2 and 3 are the sample ID and the dilution factor. The user can input a custom sample ID as well as a dilution factor based on the final dilutions of the cell on the slide, the cells in the slide. And I'll go more into that a little later. Number 4 is the assays available for selection. At this time, we only have 2 available, but it's possible to add more assays as you develop custom assays or custom cell types. Number 5 is for once we've selected an assay and we've inputted our sample ID and dilution factor and have loaded our sample into the instrument, we can preview the image of the cells. This is a live image of our cells in the counting chamber, and we can focus our sample and count there. Number 6 is a feature that allows the user to reload a previously saved image, counted sample images from a USB stick or a network location. Number 7 is where to find the settings that allow the user to customize the saving options for data and images, or to auto-print the results and other service options. And finally, number 8 is the help option. This is where the user can find an electronic copy of the user manual and also how and where to get help or support for this author. If your Auto 1000 has internet access, from here you can also find online tutorial videos and frequently asked questions in our support page on our website. So now we can move on to how to perform the Trypan Blue assay. It's a very simple assay, and it can be used for cell lines or primary cultured cells. You start by diluting a small amount of Trypan Blue 1:1 with PBS, phosphate buffer saline, to give a final concentration before mixing the cells of 0.2%. Often it comes from the vendor at 0.4%. If the Trypan Blue you're working with is of an older stock, you may be required to filter it, and that will remove any crystallized fragments that can get into our slide. So once you've done that, mix the Trypan Blue 1:1 with your cell sample and load 20 microliters into the counting chamber, and it's ready to be imaged. So now I have some images. This is the HT29B4 cell line, which were derived from human colon cancer cells. This image was taken with the Auto 1000, and we can see that this is a clean, consistent sample with nice round cells with bright centers. But you can also see the Trypan Blue positive cells stained with blue and that are less defined. I also have images of cells stained with Trypan Blue using some of our other instruments. So here we have the SF9 insect cell line, and this image was taken with an Auto T4. And this is also a nice clean sample again, and you can see the clearly Trypan Blue positive cells, though they're not too many. And the next image is of the A549 cell line, and this was taken with a Cellometer vision, which does not have a color camera, but we can clearly see that these dark cells are Trypan Blue positive. So now I'll do a really quick demo of the Trypan Blue Viability Assay. And I will switch to the software very quickly. So here's our home screen that we are now all familiar with. My selected assay is the Trypan Blue Viability Assay, and you can see here. I can set my sample ID and dilution factor, but those are already set for me. I'm at a dilution factor of 2 because it was stained 1-to-1 with my cells. So we're going to look at our images of our cells, and you can see here on the left are our focusing buttons. We have a coarse focus knob and a fine focus knob, just like a typical microscope would have. Typically, for Auto 1000, you will not have to focus between slides. They'll stay very consistent. Mostly you want to focus between cell types. So now I think everything's focused and fine, so we'll click the count button down here, and we'll give it a couple seconds to count. And now that it's finished, we have our results table, which is popped up. This gives us our total live and dead cell count, concentration, and mean diameter, as well as our viability of our sample, 78.2. And now we can leave here, the results table, and we can view the details of our counting results. And this is our image, and we can click View Counted Image to see what was counted as live and what was counted as dead. Outlined in green are the live cells, and outlined in red are the dead cells. This is also where you would find your histogram, which we'll talk about later. So this is our assay. It's very simple, and we can go back to the presentation now and talk a little bit about the data management. So back to the sample ID and dilution factor. I know we already talked about it a little bit, but I'll go on about it more. The sample ID is very useful for organizing your data. Each sample is customizable for easy identification between samples and to allow you to easily catalog and recall your images. And the dilution factor you put in reflects the final dilution performed with the cells prior to counting in the Cellometer. We have a quick cheat sheet of how to calculate the dilution factor, which is the total volume over the cell sample volume. In the Trypan Blue experiment, the cells are typically stained 1-to-1 with their Trypan. Therefore, if you stain 10 microliters of cells with 10 microliters of Trypan Blue, your total volume is 20, and the dilution factor is 20 microliters divided by 10 microliters, which is 2. So next is our cell size histogram, which is available after counting, and you can find it when you're looking at your counted cell images where I showed you. This histogram is automatically generated and can be used to optimize cell size parameters, to exclude debris, or to identify a specific population of cells with a sample. So next, there's also the auto-saving feature found in settings in the home screen. When it's turned on, it allows the user to save to a specific folder and to generate data reports. This ensures that your samples are saved to the right place every time, and it allows the user to quickly go through a series of samples. And finally, there is an auto-printing feature also found under the settings from the home screen that allow users to automatically print the results template after each count. So that concludes the basic tutorial of the Auto 1000 and the Trypan Blue Viability Assay. Are there any questions?
Great. Thank you, Stephanie. So at this point, if you do have any questions based on what was covered today, or maybe just based on the own research on what you're doing in your lab with your team, please feel free to type your questions into the question box, and we'll be able to address those for you. All right, so I do have one question here so far, and it is asking, why would we want to auto-save our images?
Auto-saving your images actually will ensure that they're in the right place where you want them. It's very organized, and it actually will go through your sample testing very quickly. And if you ever have any trouble with it, you can also call into me at support.
Great. All right, we've got somebody with their hand raised. If you can, Sue, if you have a question and you can type it into the question box, that is the best way to have any questions answered. Okay, so Sue has asked, thank you, Sue. Sue has asked, what is the best way to limit the debris that gets counted?
Well, you can adjust your cell size parameters. On that histogram I showed you, you'll kind of see two peaks. You'll have your small debris peak towards the lower end, and then your real population of cells. And with that, you can kind of gauge where you want your minimum cell size to be and where to cap it off at.
So if we have two different sizes, with our debris being one size and our cells being another, we can adjust our gating.
Yes.
To let the instrument know what it should be excluding.
Yes.
Okay, great.
And if you ever have any questions like that to optimize an assay, you can also call into support and send us some images.
Absolutely. I would say another benefit of excluding debris would be a fluorescent staining, AOPI. It's a nucleated stain, so especially if you're working with a very messy sample that has a lot of debris, it won't even pick up any of that. One of the problems and challenges with Trypan Blue can be staining of non-nucleated cells, which make it look like a counted dead cell.
This is very true.
Okay. Let's see, any other questions out there? Oh, we have another question.
Yeah.
And it's saying that you had asked if you had actually talked about how you can add assays to that home screen.
Yes.
If you create your own assays. So the question is asking, isn't there a library of assays that Nexcelom has that you can also import from?
Currently, for the Auto 1000, we only have those two assays available. For the software, we have other assays we can develop for you. But for the Auto 1000 specifically, those are the two, if you go to import, export assays that are available from our library.
Fantastic. All right, we have another question, and it is asking what is the lowest concentration and the highest concentration that can be counted?
I would say the lowest concentration, you probably don't want to go below 1 million, but you can go maybe as low as 5 times 10 to the 5th. But very low concentrations can be difficult and inconsistent. The ideal concentration is 2 million cells. But depending on your cell type, you probably don't want to go much higher than that. Like maybe 3 million might be pushing it.
Great. And it looks like you have another question about your heme cytometer manual counting not correlating specifically with viability percentage. If that is okay with you, what I'll have is one of our tech support reach out to you after and just talk through the problem a little bit after this webinar, and they can assist you with optimizing that for you.
Of course.
Okay, and do we have any other questions? All right, it doesn't look like we have any other questions at this time. If any come to you after this webinar has concluded, maybe after you've watched it a second time or someone else in your lab watches it and they have their own questions, you can always email us at support@nexcelom.com, and we'll be happy to answer any questions you may have. Again, I want to thank everybody for joining us for the webinar today. I want to thank Stephanie for putting on a great presentation. Next month, we always have our Cellometer user training webinar on the 4th Friday of every month. Next month, we'll be talking about autophagy and the vision, VA, and we'll be talking about how to create new assays and cell types and to change your exposure time. So that's going to be a great webinar as well. Again, I want to thank everybody for joining, and have a great Friday and a wonderful weekend.